It is the forerunner of an all-metal high-wing airplane using 4 Allison turboprop engines. Its design features permit quick, easy changeover from its basic cargo function to practical and efficient use for heavy equipment drops, troop transport, personnel transport, air evacuation, or wheeled vehicle loading. This replica reproduces all dimensions and equipment locations of the prototype with the exception of the wing and vertical tail. Since all 4 power plants are interchangeable, the single installation on the mock-up provides all that is needed for design evaluation. At sea level, with a normal takeoff weight of 108,000 pounds, the airplane will clear a 50-foot obstacle in 2,240 feet, as computed according to specification MIL C5011A. At an altitude over 30,000 feet, the cruise speed is over 300 knots. Performance exceeds the specification, which required carrying 25,000 pounds for a radius mission of 1,000 nautical miles and a 20,000-pound payload for a 2,200 nautical mile range mission based on a flight limit load factor of 3. Overall length of the airplane is 94 feet 9 inches. Height of the vertical tail is 38 feet 3 1/4 inches. Wingspan is 132 feet 6 9/10 inches. Wing area 1,745 square feet. The 15-foot diameter Curtiss electric propellers are full feathering and fully reversible. A camera tour around the mock-up will identify many significant design features. The large and easily removed radome houses navigational radar equipment, including an APS-42 radar modulator and scanner to assist the crew in determining surrounding terrain, detection of unfavorable weather, and to provide beacon navigation operation. The door on the battery compartment is opened without tools, giving access to a waist-high installation which rides on sliding tracks. The bottle for acid overflow sets just inside the opening. Directly adjacent to the battery compartment, the AC-DC power receptacle door is spring-loaded to prevent inadvertent opening in flight and needs no hand tools to open or fasten it. The forward cargo door, directly aft of the crew door, is hydraulically operated. This independent unit is identical with the proven system used to operate cargo doors on the Lockheed C121. The door is raised to the full open position in about 30 seconds, providing a clear opening 77 inches high by 82 inches wide. For night loading, flush-mounted lights on the inner side of the door illuminate the loading area. A release on the hydraulic unit quickly lowers the door, and positive locking latches seal the door flush with the skin. The main gear is located at the fuselage to give low drag, save structural weight, and to avoid transmittal of landing loads to fuel tanks. The tandem arrangement gives the best possible soft feel characteristics and is well suited to narrow, unpaved taxi strips and runways. Motor-driven screw shafts retract the wheels vertically, and mechanically linked doors completely enclose them. A single-point fueling station in the right side wheel well fairing has fuel control and capacity indicators laid out on a schematic diagram of the fuel system. Because of its 4-engine design, the airplane will have ample safety margins in engine-out operation. A separate detailed mock-up of the power plant and nacelle provided information on clearances, access panels, engine controls, and location of protective devices for engine overheating, fire detection, and fire extinguishing. Engine nacelles and crew station are armor protected against small arms fire. The major panels are hinged for normal access, but can be fully removed. The entire lower panel, which incorporates the oil cooler duct, oil cooler flap, and oil cooler installation, is easily removed. The clean design of the power plant nacelle presents an unusually small frontal area. Engine combustion area is isolated from both the engine accessory area and the wing by firewalls of stainless steel. Wing and flaps are protected from exhaust gas by titanium, insulation, and a cooling air passage. Aft of the vertical firewall, nacelle skin is titanium. All internal fuel is carried in the outer wing panels, which meets the specification requirement of no fuselage fuel. Total capacity of the 4 tanks is 5,546 gallons. Pylon tanks will be attached for combat operations. Each pylon carries 1,400 gallons in 2 separate inner tanks, protected on the underside by bullet sealing blankets. Thermal de-icing protects wing and empennage leading edges. This sample of an integrally stiffened structure shows the type of construction used in many places to reduce the number of parts, save production man-hours, and decrease weight. For demonstration purposes, another section of integrally stiffened panel was purposely damaged with .60 caliber gunfire to illustrate the simplicity of repair. The method utilizes sheet metal structure, sealing compounds, and flush rivets. Now let's look over the inside of the airplane. The flight station plan view identifies the working space for the pilot, co-pilot, flight mechanic technician, and radio navigator. The crew door is manually operated by handles on the outside and inside of the airplane. The doorway opening, 30 inches wide and 45 inches high, leads both to the cargo compartment and the flight station. Both areas are fully pressurized. The crew is compactly grouped without sacrificing the freedom required for efficient operation. For night operation, all instrument panels have red flood and indirect edge lighting. The flight mechanic technician, while primarily responsible for coordinating controls with the pilot and co-pilot, also operates the relay panel. The radio navigator station features a large work surface and conveniently located functional equipment controls. Window area exceeds 48 square feet, providing excellent flight station visibility. This design amply satisfies the strict requirements for low-altitude troop carrier operations, which include formation flying, airdrop operations, and for landing in restricted areas where obstacles may be encountered. The normal angle of view for the pilot and co-pilot is represented by the bright area. Expanded shaded arcs show the added visibility obtained if they move their position slightly. These wide angles provide exceptionally good visibility in all directions. In the large cargo compartment, there is a total usable volume of 6,370 cubic feet, including the space over the ramp and ramp door. For airdrops, the cargo volume of 3,850 cubic feet is measured by using only the maximum clear cross-section of the compartment below the wing center section and the length of the compartment forward of the rear ramp. The unobstructed clear cargo space is 41 feet long, 10 feet wide, and 9 feet high. At the forward end, junction boxes for AC power are covered by sliding panels. This location provides for ready accessibility when maintenance is required. DC power junction boxes are on the other side of this partition in the flight station. The space directly below contains the airplane's basic electrical control units, voltage regulators, inverters, and generator controls. The wide spacing of these elements provides for proper cooling and easily fulfills requirements of Air Force specifications. This compartment accommodates cargo tie-down equipment and a portion of the troop seats. In case of an airborne emergency, the crew door is jettisoned by a release in the flight station. Crewmen slide down a pole and out the door opening. The jump path is completely clear of the propeller. The rear doors, essentially for personnel loading and air jumps, provide emergency exit as well. For ditching purposes, there are 3 escape hatches on top of the fuselage. One above the ramp door, another in the cargo compartment aft of the wing, and a third in the flight station. In addition to the overhead hatches, the regular doors and ramp can be used for emergency escape. Also, 2 hinged window panels in the flight deck and a special emergency door on the right side forward of the wheel well are provided for ditching. There are 2 20-man life rafts in the center section of the wing on each side of the airplane. Life raft release handles are located in the flight station, in the cargo compartment, and in the wing surfaces adjoining the life raft compartments. This airplane is ideally suited to the job of transporting the many kinds of cargo required for military operations. The spacious compartment has features which contribute to efficient loadability, high utilization, and economic operation. The cargo floor and ramp are made of integrally stiffened aluminum alloy to withstand the heavy and rigorous use normal to military loadings. The ramp is actuated by 2 hydraulic cylinders located clear of the opening. The cylinders lock the ramp at the horizontal or full down position. In the down position, they serve as jacks to prevent inadvertent settling of the aft fuselage. Ramp extensions can be placed anywhere along the rear edge to suit the tread of the vehicle being moved. C130 loading time is minimized by using the large forward cargo door at the same time with the rear ramp. Between the cargo door opening and the propeller plane, the clearance is 54 inches. A variety of cargo tie-down fittings have been included to serve the airplane's various requirements. Over the entire cargo area, 10,000-pound fittings are spaced in a 20-inch grid pattern. 8 25,000-pound fittings are strategically located to secure loads of this magnitude, and numerous 5,000-pound fittings are included on the ramp and sidewalls. For small loads of relatively light density, the most convenient tie-down method utilizes cargo nets secured by straps. Another method for tying down box-type cargo is by straps alone. Such loads can be very quickly secured anywhere in the compartment because of the abundance of tie-down locations. For bulky cargo, such as the J-33 engine container, D2 military chain equipment can be employed. Selective location is not necessary due to wide distribution of available 10,000-pound fittings. All fittings are flush-mounted in easy-to-clean recesses. The cargo area will accommodate 6 J-33 engine containers. Troop and paratroop seats and related equipment are easily set up. Removable stanchions lock in along the middle section for support of the center seats. A pair of aft stanchions also serve as a ladder to an emergency ditching hatch in the top of the fuselage. The compartment is fully pressurized. Standard troop seating provides for 92 men at 20-inch intervals. For paratroops, the seating provides for 64 men and their equipment, spaced at 24-inch intervals. In the quickly installed litter arrangement, heating, cooling, and pressurization systems provide comfort for wounded personnel. The maximum setup accommodates 74 patients, plus seating for 2 attendants, and an alternate arrangement allows for 70 patients, plus seating for 6 attendants. There are 2 wide aisles and ample space for attendants to care for patients, even with 5-tier spacing. For comfortable long-range movement of personnel, the C130 can be equipped with 55 aft-facing mats-type seats, which can be quickly installed in the standard 20-inch grid fittings. The design also provides for galley, baggage, and toilet facilities. This high-speed tractor and 155mm howitzer make up a typical combat vehicle loading. We see the tractor coming in first, but under operational conditions, the howitzer would be backed in. Weight of this vehicle load is 35,725 pounds. A D6 tractor with bulldozer attachment demonstrates the loading of a cleated vehicle. Although the C130 has an integrally stiffened metal floor, it is desirable to use plank protection against cleats. Total weight here is 21,380 pounds. Unused space fore and aft of the equipment is practical for additional loads to utilize maximum payload capabilities of the airplane. Loading a motorized road grader requires swiveling the 12-foot blade to clear the side walls of the compartment. This typical C-130 load weighs 23,320 pounds. When the ramp is horizontal with attachable extensions in place, a continuous flat surface is provided from ramp to truck bed. With the ramp horizontal, the cargo compartment opening is 9 feet high by 10 feet wide, matching the minimum cross-section of the compartment interior. The road grader demonstrates the ease of unloading to truck bed using a standard C2 semi-trailer. The 50-foot C2 semi-trailer is one of the longest vehicles the C130 will accommodate. An M38 truck makes up a sample supplementary load. The C130 floor structure will accommodate single axle loadings of 13,000 pounds. Single wheel loadings of 6,500 pounds in treadway areas under all ground loading conditions. The normal density loading is approximately 500 pounds per square foot, or 1,000 pounds per linear foot of fuselage. The trailer's length is greater than the cargo compartment floor, yet the ramp and ramp door are fully closed. Combined weight of these vehicles is 15,625 pounds. Another standard vehicle is the Air Force F-6 5,000-gallon tanker, pulled by a 5-ton truck tractor. 8 feet in width, the tanker is readily loaded and leaves ample clearance along the fuselage interior. This combined load weighs 26,960 pounds without fuel. Completion of the C-130 mock-up marks a major step in the development of one of America's great new cargo airplanes. The important problems of basic design have been resolved. The construction of a prototype is underway, and a production order has been assigned. Performance forecasts, combined with extensive mock-up development, assure both manufacturer and user that production versions will meet the requirements for a versatile, high-speed military transport ideal for wheeled vehicle loading, truck bed loading, heavy equipment drops, personnel transport, troop transport, paratroop drops, and for air evacuation.